Venkateswarao, read in chemistry, Andhra Royal College, Vijayawada. I would like to show a video on determination of hardness of water. Determination of hardness of water by complex symmetric titration. Hard water. Hard water is due to metal ions that are dissolved in the groundwater. These minerals include calcium ions, magnesium ions, iron ions, sulfate ions, and bicarbonate ions. Our hard water is due to rain moving through the vast amount of limestone, that is calcium carbonate, that occurs in our area to the aquifer. This is why we measure hardness in terms of calcium carbonate. The concentration of calcium ions is greater than the concentration of any other metal ion in our water. Concerned about hard water. The determination of water hardness is a useful test that provides a measure of quality of water for households and industrial uses. Originally, water hardness was defined as the measure of capacity of the water to precipitate soap. Hard water is not health hazard. People regularly take calcium supplements. Drinking hard water contributes a small amount of calcium and magnesium towards the total human dietary needs. The National Academy of Science states that consuming extremely hard water could be a major contributor of calcium and magnesium to the diet. Hard water does cause soap scum, clogged pipes, and clogged boilers. Soap scum is formed when the calcium ion binds with the soap. This causes an insoluble compound that precipitates to form the scum you see. Soap actually softens hard water by removing the calcium ions from the water. When hard water is heated, calcium carbonate precipitates out, which then clogs pipes and industrial boilers. This leads to malfunction or damage and is expensive to remove. Water softeners. If you have hard water, you may use a water softener to remove the hardness. Salt is mixed with water. The sodium ion from the salt replaces the calcium ion, but this causes the water to be too salty for drinking. Water that has been softened should be used only for laundry and bathing. We would like to know about types of hardness. There are two types of water hardness. Those are temporary hardness and permanent hardness. We would like to know temporary hardness. Temporary hardness is due to the presence of bicarbonate ion in the water. This type of hardness can be removed by boiling the water to expel the carbon dioxide, as indicated by the following equation. Bicarbonate hardness is classified as temporary hardness. Now, we would like to know about permanent hardness. Permanent hardness is due to the presence of the ions calcium, magnesium, iron, and sulfur. This type of hardness cannot be eliminated by boiling. The water with this type of hardness is said to be permanently hard. How hard is water? The degree of hardness of the water is classified in terms of its calcium carbonate concentration as follows. This slide shows hardness rating and concentration of calcium carbonate in milligram per liter. 1 milligram per liter is equal to 1 ppm. 1 ppm is equal to 1 parts per million. For soft water, the concentration of calcium carbonate is 0 to 75 ppm. For medium hard water, the concentration of calcium carbonate is 75 to 150 ppm. For hard water, the concentration of calcium carbonate is 150 to 300 ppm. For very hard water, the concentration of calcium carbonate is 300 and greater ppm. What is complex symmetric titration? In this complex symmetric titration, we use EDTA to measure hardness. Permanent hardness is usually determined by titrating it with a standard solution of ethylene diamine tetracetic acid, that is EDTA. The EDTA is a complexing agent or chelating agent used to capture the metal ions. This causes the water to become softened, but the metal ions are not removed from the water. EDTA simply binds the metal ions very tightly. What is EDTA? EDTA is ethylene diamine tetracetic acid. EDTA is versatile chelating agent. What is chelating agent? A chelating agent is a substance whose molecules can form several bonds to a single metal ion. Chelating agents are multidentate ligands. A ligand is a substance that binds with a metal ion to form a complex ion. Multidentate ligands are many clawed holding onto the metal ion to form a very stable complex. EDTA can form 4 or 6 bonds with a metal ions like any. This slide shows the structure of EDTA. What are uses of EDTA? It is frequently used in soaps and detergents because it forms complexes with calcium and magnesium ions. These ions, which are in hard water, are bound to the EDTA and cannot interfere with the cleansing action of the soap or detergent. Again, we concentrate on use of EDTA. EDTA is also used in foods. Certain enzymes are responsible for food spoilage. EDTA is used to remove metal ions from these enzymes. Why do we heat the water? We heat the water to make sure all the calcium ions and other metal ions are dissolved in the water. If they are not dissolved in the water, the indicator cannot form a complex with them, and your endpoint will not be the true endpoint of the titration. Total permanent hardness. In this lab, you will be asked to determine the total permanent hardness. EDTA grabs all the metal ions in the water, not just the calcium ions. This gives us a value that is not truly the concentration of calcium ions. This causes an experimental error of about 1%, which is acceptable due to the fuzzy endpoints in this type of titration. Now, let us concentrate on units of hardness. The first one is parts per million. Normally, we use this hardness in our laboratory. The second one is milligram per liter. 1 milligram per liter is equal to 1 parts per million. So, third one is Clark's degree. Fourth one is degree French. This slide shows the relationship between various units of hardness. I already mentioned about the equivalency of ppm and milligram per liter. 1 ppm is equal to 1 milligram per liter. That is equal to 0.1 degree French. That is equal to 0.07 degree Clark degree of hardness. Now, we concentrate on experiment. What are the reagents required for the experiment? So, number one, standard EDTA solution we have to prepare in the lab. Number two, buffer that should show pH around 10. We have to prepare this also in the lab. The buffer is a mixture of ammonia and ammonium chloride solution water. Third one is aerochrome black indicator that is there in the lab. Number four, burette. And fifth one is pipette. Procedure for experiment. A 50 ml sample of tap water is taken in a conical flask. To the sample, add 5 ml of buffer and 3 to 5 drops of aerochrome black indicator. Titrate with EDTA from a 50 ml burette and note when the color changes from red to blue. So normally you will observe wine red color that changes into blue at the end point. Repeat the titration 2 more times to accurately measure the total magnesium and calcium ion concentration. Are you interested to know about aerochrome black indicator? Yes. Aerochrome black indicator or aereo T indicator is used in this titration. When it is chelated or acidifies, it produces a wine red or pink red solution. When it is not chelated and under basic conditions, it is blue. The picture on the left shows the color of the indicator before titration. The 3 pictures to the right show the end point in this titration. There is a 1 drop difference of 0.01 molar EDTA between the first and second pictures and between the second and third pictures. 2 or 3 seconds were allowed for colors in the second and third pictures to develop after adding the additional drop. EDTA endpoint color change. In each case, the solution was thoroughly mixed. This color change from wine red to violet to blue is due to the compact nature of the complex. The statement, the compact nature of the complex, means when the indicator is added to the hot water, the indicator aerochrome black T forms a complex with the calcium ions that is pink in color. As EDTA is added to the solution, the EDTA forms a complex with calcium ions, leaving the indicator aerochrome black T uncomplexed, which is blue in color. Now let us concentrate on calculation. That is sample problem. You are using EDTA with a molarity of 0.0080 for the titration. You titrate 50 ml of water sample using 10.68 ml of EDTA. This slide shows what is the concentration of calcium ion. Now you observe the calculation. What is the answer you are going to get? That is 0.0017 molar. This slide shows what is the hardness. See the calculation. You will get the answer, that is 170 ppm.